In this video, I'm going to actually talk about something that is a little bit above what we need to know at the grade 8 level, but I had especially one student really wondering about this pattern, and so I thought that I would spend a little time on it, and it actually confused me for a little bit as well. So I wanted to allow people to see what's going on here and talk about how we can use a T-chart to help find these patterns. So, what had happened was in a question, there was rows of cans stacked on each other, and they gave us that the pattern was sort of going up in this way. And so first of all, I did want to point out, in any sort of pattern we have like this, we consider this the first term, or I'll just put a 1. We consider that the first term, we consider that the second term, the third term, the fourth term, and so on. And generally, what we've started now doing, we've called it a few different things, but right now we tend to call that n. So term number n. And I'm gonna continue to use that. So in our so if we were to create a T-chart using this information, we could start off by having a row for n, and then also having whatever our value is. So in this one, our first value for term 1 is going to be 2 times 3, which is 6. Our second one is going to be 4 times 6, which is 24. Our third one is 8 times 12, which is 96. And our fourth one is 16 times 24, which is 384. Okay, now, so one of the students I was talking to correctly pointed out that there is jumps here. And usually we're used to seeing jumps where it's adding something. So anything that we've done, or most of the things we've done so far, this will be increasing by a certain amount. So I could have said that this is increasing by 18. But then this doesn't work because this increases by more than 18. But what the student said was that this actually increases by timesing by 4. And again, jumping from 24 to 96, again, it's timesing by 4. And jumping from 96 up again, we're continuing to times by 4. So this pattern is continuing and continuing and continuing. So the student had asked me, like, if I was trying to find a very high number, say 100 or 200 number of this stack of cans, how could I do that using an expression? And I thought about it for a little while, and then it sort of came to me that when we were doing anything where we're taking a multiple times 4 times 4 times 4, that's actually just a power. Like, we can say that that's 4 to some power. So in this case, our first jump we're making is 4 to the power of 1. But if we're multiplying it by 4 twice, that's to the power of 2. If you remember back to factoring, we can also think of it that way. So if I wrote the numbers along in a line, I'll use the black color here. If I wrote the numbers along in a line, our first number is 6. Our next one's 24, 96, and 384. Well, every time we're increasing here, we're multiplying by 4. So 24 is the exact same thing as me saying 6 times 4. I can say that. Just like 96 is the exact same thing as me saying 24 times 4. Or 6 times 4 times 4. 384 is 96 times 4, or 6 times 4 times 4 times 4. So if you remember in our factoring, we tried to break down numbers that way. I know that 6 is not a prime, and neither is 4 for that matter, but still we did break down our numbers in this way. So I started thinking, okay, well, really, what I need to do is 6 times 4, and then it's really to whatever power I'm looking for. This is where it gets a little bit tricky, because if I just did to the n, which would make some sense because our first term, second term, third term, then that's going to give me the 24, the 96, the 384, but it's not going to give me the 6. So that was adding a little bit more complication onto that. However, and we have not learned this in grade 8 yet, but if you have something that's to the power of 0, so on my first term, so when n equals 1, if you have something to the power of 0, that number is always going to be equal to 1. It's a bit of a mathematical trick, but just go with it for right now. Or even if you almost just ignore this first number, then you can see how this would work for all the other numbers. So if we had the 24 being our second term, I'm going to put the term numbers in blue just so we can see what they are. So our first term number was 6, our second term number is 24, then 96, then 384. So if you can imagine our second number being 24, well, if I multiplied 6 times 4 to the 2 minus 1, well, 2 minus 1 is just 1. So 4 to the 1, we have learned about that. 4 to the 1 is just 4. It also works for our 3 here, because if it was 3 minus 1, that would be 2. So I'll write this one down. 6 times 4 to the 3 minus 1 is 2, so 4 squared is 6 times 16. 6 times 16 is going to give us 96. And this same pattern continues to work. So even though this kind of expression is not what we're looking for at the grade 8 level at this moment, you can still see that there is a pattern that can work. And if you're wanting to take math to sort of another level, then this sort of pattern can work for these slightly more challenging patterns that we're dealing with in our t-charts whenever we notice that there's a multiplying happening here. I hope this has been interesting and helpful.